The first keynote session is on artificial intelligence, good news, bad news, or simply fake news. We have a rock star speaker today, and it's my honor to introduce Mr. Tanmay Bakshi, or should I say Master Tanmay Bakshi, the world's youngest IBM Watson coder. He truly should be referred as a Master Bakshi for more reasons than age alone. Inspired by watching his father programming at the age of 4, he started programming and had his first app on Apple Store at the age of 9. Tanmay Bakshi, age 13. Ladies and gentlemen, age 13, is a software developer, algorithmist, honorary IBM Cloud Advisor, IBM Champion for Cloud, author of Hello Swift, author at 13. He shares his knowledge with the world through his YouTube channel, Tanmay Teaches. He is a host of IBM Facebook Live series, Watson, Made Simple with Tanmay, has taken a resolve to help 100,000 kids and beginners on their journey to innovate through coding. Supports initiatives like STEAM, Everyone Can Code, Girls Who Code, and Kids Can Code. Ladies and gentlemen, presenting to you child prodigy of today and thought leader of tomorrow, Mr. Tanmay Bakshi.
A quick video clip and then we'll start. So if we get my Mac on screen, that would be great. Is it turning on? Okay, great. Just give me just one moment. I think it might have turned off there.
Welcome to the closing general session of Interconnect 2016.
Our next guest is a software developer specializing in iOS, Mac OS X, and Watch OS development in Swift and Objective-C, along with Java and Python. In the meantime, please join me in welcoming to the stage Tanmay Bakshi.
This is not about replacing humans. This is about taking what humans are good at, which is of course learning, and taking what computers are good at, their extreme mathematical skill, combining them in order to create such a powerful combination that can, as I said, change so many people's lives. So I was actually trying to create a data set that would work with shallow neural networks, and I could just feed it into a shallow neural network and have it give me output. And this time we're going to be going over how you can use SiriKit with the new iOS 10 frameworks that Apple released in order to create a messaging application. What this means is it's essentially a biological neural network in your brain, literally with neurons and synapses and dendrites in your brain that we're mapping out onto a computer on a much, much smaller scale. And this time we're going to be going over how you can use IBM IoT, IBM Watson Conversations, and Node-RED to control a drone. More specifically, the Parrot AR Drone 2.0. Send the message and look at the drone. Alright, it has now taken off, and as you can see, the drone is taken off, and now we can let it fly, but let's say we want it to land, right? All you need to say, land the drone. Alright, I'm going to send this text message, and now watch the drone. Thank you. So hi there everyone, and welcome to my keynote at NASSCOM's Big Data and Analytics Summit. I'm sure you've already been having a great time at the conference so far, and of course the next 2 days are going to be filled with a lot of fun and exciting activities, and of course there are going to be great, amazing events at this conference. Now let's start off with a little bit of an introduction about me. Starting off, my name is Tanmay Bakshi. I'm in the 8th grade and I live just outside of Toronto in Brampton, Canada. But of course, I would also like to say a big thank you to the team over at NASSCOM and President Chandrasekhar for actually inviting me to speak at this amazing event. Of course, starting off with a little bit of my background. I am a software and cognitive developer, as well as an algorithmist at Darwin Ecosystem. I'm also an author, keynote and TEDx speaker, a YouTuber, a course instructor for Udemy, an IBM champion for cloud, and an honorary IBM cloud advisor. But going into a bit more detail, as I mentioned, I am a YouTuber and I have a YouTube channel called Tanmay Teaches with over 17,000 subscribers and over 137 videos. On this channel, I absolutely love to teach about topics like computing, programming, algorithms, machine learning, Watson and artificial intelligence, math, science, and of course, neural networks, which in fact I will be getting into in just a little bit. But as I also did mention, I am an author, and I've written a book called Hello Swift, iOS App Programming for Kids and Other Beginners. And as the subtitle suggests, it's basically a book for kids and other beginners to learn iOS app development through Swift from scratch. But then, this brings me to the reason that I'm actually here today. Why you're listening to me today. And of course, that is artificial intelligence. But more specifically, is AI good news for humanity? Is it bad news, or is it just all around fake news? Well, I truly believe that artificial intelligence is most definitely good news for humanity. And in fact, in the next 30 minutes, I'm going to tell you why I believe artificial intelligence is such good news for humans. But of course, though, which AI talk would be complete without talking at least a little bit about IBM Watson, a cognitive computing platform by IBM that was not only able to play, but also win Jeopardy against the two best human competitors in 2011. Of course, Watson has now been converted into a set of tools that developers like us can use in our applications in order to create intelligent and smart applications. In fact, Watson is very powerful. I've been able to create many different projects with the extremely powerful capabilities that Watson provides. In fact, these projects range in fields all the way from healthcare and education and entertainment, all the way to utilities, security, and business. In fact, these are just a few of the different projects that I've worked on using IBM Watson's cognitive capabilities. But out of all of these projects and more that I've worked with, there are two that I think you'd be most interested in, and two that I want to share with you today. It started off with my very first IBM Watson project, Ask Tanmay, an open source NLQA, or natural language question answering system, that can answer your person, organization, and location questions. I like to call Ask Tanmay a cognitive analytics engine for big data that's gathered from search engines. What this basically means is that we're able to gather big data from huge data repositories like Google, Bing, and Yahoo, and we're able to run cognitive analytics on it to try and find natural language, unstructured answers to your natural language, unstructured queries. It's very interesting how this actually works. And of course, it's built off of IBM Watson's natural language understanding and natural language classifier services. In fact, it's actually the world's first web-based NLQA system to be powered by IBM Watson. In fact, this here is actually a flowchart of how the Ask Tanmay system actually works. We don't really have too much time to actually go into depth about how this works, unfortunately. But a quick overview is that, of course, Ask Tanmay starts off with some sort of input that the user gives to it for it to do its analytics on. And in this case, that input would be the query that the user has and the multiple choice answers to choose from. Again, these are optional because Ask Tanmay can actually answer questions that don't contain multiple choice answers. After that, Ask Tanmay will run the big data gathering step, basically. And what this is it's the search engine results summary extraction phase, where it'll go to all these search engines like Google, Bing, Yahoo, and it'll actually try and gather all the big data that it'll actually mine for answers that relate to your query. After that, of course, the candidate answer generation and answer type detection phases will be run in parallel. Answer type detection will use the IBM Watson natural language classifier service to try and find out exactly what your question is actually looking for. And candidate answer generation will actually try and find out different answers that could be the answer to your question. Then it'll go over to the named entity recognition phase. And named entity recognition will use the IBM Watson natural language understanding service to actually try and filter down the answers to only those that are actually possible to be the answer. Then, of course, it'll run some auxiliary steps like full name scoring, duplicate candidate merging, and query answer removal to basically take higher quality answers and raise them to the top of the list, and lower quality answers will get further down in the list. After that, finally, it'll use a custom deep learning algorithm that uses custom natural language processing to score all the hypotheses that it has, and after that, it will, of course, give the top 5 answers to the user for them to choose which one is actually correct. That's actually a quick, brief overview of how Ask Tanmay actually works. But next, there is another project, another Watson project, that I think you'd find very interesting. This Watson project is called Tendril. Tendril stands for Tanmay's drone. The basic point is that you should be able to co-pilot a Parrot AR drone 2.0 using text message, more specifically using a chatbot via a text message gateway. This is very interesting how this works. In fact, it's actually so interesting to the point that I was actually live demoing a drone on stage for the very first time just a few weeks ago in San Francisco. And you can actually see me keynoting here with Jeff Lawson, the CEO of Twilio, at their Signal 2017 conference. And so I was actually able to demo the Tendril system there and how exactly you can actually co-pilot a drone using text message via a chatbot powered by Watson Conversation. But going into a bit more detail, how this actually works is you are able to text message a phone number with your commands that you want the drone to execute. For example, take off, you can land, you can rotate, you can go up, down, left, right, forward, or backward, whatever you want to do, and the drone will execute that command. The best part is, again, remember, this is AI, this is cognitive. You can phrase your message however you'd like to. You can say take off, fire up the engines, lift off, whatever you might want to, and it will understand the intent behind your message, and it'll then execute that action on the drone accordingly. In fact, the best part about this is that not only can you send information to the drone, you can actually receive information from the drone. There's actually a structured JSON data stream coming from the drone to the chatbot's context variable. What this means is the chatbot is quite literally contextually aware of the drone's existence and a lot of information about the drone. And so what you can do is you can actually query the drone, query the chatbot for some information about the drone that data stream has using an unstructured query. Quite literally, you are querying a structured data set with an unstructured query. For example, you can ask it for battery, altitude, accelerometer, gyroscope, magnetometer, and so much more data through a natural language interface. It's very interesting how Tendril works, and again, this is just one example of how something even more practical than this could be implemented with systems like Watson Conversation and Twilio. In fact, I also have a dedicated playlist to IBM Watson on my YouTube channel called Tanmay Teaches Watson. And I'm also the host of an IBM Facebook Live series called Watson Made Simple with Tanmay, where I show you how you can integrate IBM Watson's cognitive capabilities in your applications on a variety of different platforms, whether it be mobile, web, or desktop, whether it be Swift or Node.js or Java. I show you how you can mash up these different Watson services to create very powerful and practical use cases and applications for your users, to create intelligent applications for them. But of course, course, for Watson to be this powerful, it needs an even more powerful backend to work with. And not any machine learning algorithm can power a system like Watson. It has to be a special machine learning algorithm, deep machine learning. You probably have heard of this as deep learning. And I haven't just worked with deep learning through this very convenient Watson gateway. I've also worked with deep learning through my own custom implementations of the code. In fact, I've also worked with deep learning in fields, again, ranging all the way from healthcare, education, and entertainment to utility, security, and business. Again, these are just a few of the different projects that I've worked on with deep learning capabilities embedded in them. But out of these, there are two main projects that I think, again, you'd be very interested in. And in fact, it starts off with entertainment. Of course, entertainment's a great field. AI can be implemented in a lot of different ways. But instead of me telling you about my first project with deep learning in the entertainment field, Make Your Own Mozart, I'd like you to listen to it instead. Right now is a song that might sound familiar to you if you've ever heard a Mozart or a Beethoven piano sonata. But if you think this was composed by Mozart or Beethoven, unfortunately I'd have to tell you that no, this piece was not composed by either Mozart or Beethoven. This piece was actually composed entirely by a neural network. That's right, AI is actually learning to be creative now. It's actually very interesting how a system like this works. In fact, I'd like to tell you a little bit more about this. The real heart and soul behind Make Your Own Mozart is an LSTM-RNN, or a long short-term memory recurrent neural network. You don't necessarily need to know what this means, but basically, LSTMs are a special type of neural network that were built from the ground up, dedicated towards understanding and generating time series of data. In fact, what I'm able to do is feed in 69 of Mozart's piano sonatas and 114 of Beethoven's piano sonatas into this LSTM, and the LSTM learns everything about music. I do not give it anything to start off with. It learns how to generate valid music notation. It learns how to actually, for example, repeat the chorus every time. It learns what types of notes come after other types of notes. It learns all of the complexities and the abstractions of music, and then it's able to generate its own new, original pieces for us to work with. And in fact, what you just heard was one of the first songs that it actually ever created after listening to these songs for only about 6 to 7 hours. It is really interesting, again, how these LSTMs can be used in so many different fields. But you're probably wondering then, well, sure, I've created Make Your Own Mozart that allows you to generate music, but why? Why did I create Make Your Own Mozart? Well, then again, why is Google Brain's team dedicating a significant amount of their time and resources to a project called Magenta? And Magenta is actually a project by Google Brain that's dedicated to generating art via neural networks, art being pictures, paintings, and music. Well, think about this. Magenta, of course, is trying to advance neural network algorithms. But there's more practical use cases for these as well. For example, I am a YouTube content creator. I create YouTube content, and I don't want to use copyrighted music, but I also definitely don't want to use royalty-free music because that's been overused too much. What do? Well, I take that royalty-free music that I have the right to, and I actually go ahead and feed it into Project Magenta or my Make Your Own Mozart system. And it eventually learns everything about this music and starts to generate its own new original sounding music based off of that royalty-free music that, again, I've got the rights to and that I can use in my applications. But then you're saying, well, that's not good news for humans. We're replacing humans. We are replacing these great artists like Mozart and Beethoven. How is that good news? That's just creepy. Well, think about this then. This system was trained by humans. It learns to imitate great artists like Mozart and Beethoven and create pieces that sound as if they were composed by either of those great artists. It's not the other way around. The AI is not teaching humans. And plus, the AI is not creating my YouTube content. It's augmenting my ability to create better YouTube content for my subscribers that they can learn from. And again, this is just one small example of how an application like this can be used in our everyday lives. But now, though, I'd like to take you to another field of AI. In fact, this field in AI is one where I believe AI has been used the most to augment and amplify human skills and capabilities. And this field is, of course, healthcare. In fact, I'm actually part of a project that is very close to my heart, and it's called the cognitive story. The basic point of the cognitive story is to augment the lives of people, and to do this through the power of cognitive. In fact, this project is actually a collaboration effort between Darwin Ecosystem, IBM, Not Rocket Science, and me. The first chapter in this cognitive story is to help those with disabilities and special needs to allow them to live better, fuller, and easier lives. In fact, I'd now like to play a quick video clip describing Boo's story, the girl behind the first chapter of the cognitive story and the cognitive story itself.
The trip to meet Boo started with a simple tweet from the friend of a mother wondering if artificial intelligence could be used to help a severely disabled 29-year-old woman communicate with her family. Soon, IBM's Tim Duncan reached out to Darwin Ecosystem's Thierry Hubert to explore the possibilities. Within weeks, the two companies organized a research trip into the rural community just north of Toronto, where Boo lives a solitary life, having almost no contact with the outside world. The pair was joined by 13-year-old Tanmay Bakshi, who was recruited to join the team because of his skills with neural network systems. The road to Boo's hometown was sometimes desolate, sometimes blustery, but by the time the team reached the small town, the sun was bright and the sky was blue. It's not home to many, a hamlet like many others, but in this borough, the developers were coming to see just one resident. They arrived at Boo's ready to learn and understand a woman who can only communicate the broadest of concepts, and only to those most intimate with her condition. Her name, Boo, comes from a sound she could make as a baby, but can no longer make. Boo is quadriplegic, suffering from Rett syndrome, a rare and debilitating neurological disorder. But her parents know when she's happy, when she's irritated, or when she wants to watch TV, the simplest of desires interpreted by the most intimate knowledge. Now the hope is that artificial intelligence can match EEG signals from Boo's brain to what her parents say she's thinking, and a unique language born from cognitive computing can act as Boo's translator to others and relieve her isolation. The team includes Darwin Ecosystem's Thierry Hubert and Ross Power, Tanmay Bakshi, along with IBM CTO Rob High and innovation engineer Tim Duncan. Rounding the list, Darren Gudgeon of Not Rocket Science, who will help expand the effort to other disabilities. Darwin Ecosystem is leading the solution development that includes the hardware and cognitive software using the EEG signal patterns by feeding those patterns to a cognitive system powered by IBM Watson and Bluemix. And that interpretation may become Boo's unique AI dialect.
So now that you know a little bit more of the story behind the cognitive story and what we're actually trying to do for Boo, I'd now like to take you a little bit deeper into the technical part of the cognitive story to show you what we're actually doing. Of course, it starts off with the data that we're able to collect from Boo to try and decipher and translate into what she's actually trying to convey. The way that we decided to go about and do this is through EEG brainwaves. In fact, you can actually see a prototype version of the headset that's actually going to be gathering these EEG brainwaves from Boo. But of course, once I've gotten these EEG brainwaves, it's then my responsibility, to actually incorporate deep learning algorithms to make sense of and understand those brainwaves, and to basically translate it into what she's actually trying to convey so that she can actually try and communicate. But of course, deep learning is just a huge umbrella term. Deep learning could mean a lot of different types of neural networks. However, one that I'm currently working on right now is, of course, the LSTM neural network. That's right, the exact same algorithm that's powering music generation in the entertainment field is now powering giving communication to those who cannot communicate naturally in the healthcare field. So what I'm basically doing with these long, short-term neural networks is I'm taking this time series of data. Every 1 second, I'm getting 250 data points from this headset. That means every 250th of a second, I'm gathering 16 values from this headset. Multiply those two values together, and you see that every second, I'm getting 4,000 individual values. LSTMs were designed to crunch these types of numbers. And that's because they handle time series and quantitative data. Because think about this. So you've got 1 second data, meaning 250 data points. Each data point containing 16 values, okay? The LSTM will find patterns not only within each data point, it'll also find patterns across data points and across elements in those data points. It's generally really interesting how these LSTMs work and how you're able to use them to quite literally understand EEG brainwaves. But then you're probably wondering, well, how are we going to train a supervised learning system that's powered by neural networks if we can't understand Boo? Wouldn't we use an unsupervised learning algorithm? Well, no. You missed something. There is someone who can understand Boo, and that is her mother. Boo's mom is her intimate interpreter. She can understand the very broad concepts that Boo tries to convey, and with her help, we're going to live label this training data as it's gathered from the headset to actually train these LSTM neural networks. But I do know, though, that a lot of you here are developers. And so you're probably wondering, well, that wasn't enough. I want more. I want to hear more technical stuff. You want to get to the nitty-gritty of the cognitive story. But unfortunately, we don't really have much time for that today. But this announcement is definitely going to be very exciting. The Cognitive Story project is actually 100% open source. It's completely open source from all ends of the spectrum, it's from A to Z completely open source. Whether it be the cognitive code that actually tries and understands the EEG brainwaves coming from the headset, whether it be the actual headset schematics, the 3D printed headset schematics, or whether it even be the data gathered from the headset. It's all open source, and we welcome you to contribute to the Cognitive Story, whether it be helping us gather more data, helping us create a more comfortable headset for Boo so she's more comfortable in her day-to-day life, or whether it be helping us develop better cognitive code to develop much more accurate deep learning systems. We also welcome you to, of course, learn from this cognitive code that we're creating, learn from this entire project that we're making available to you. And of course, we invite you to use this project and use this code that we're giving to you on anybody else that you think may benefit from this code, and anybody else that you think might, of course, take something away from using this project. And of course, if you'd like to be notified about updates about the Cognitive Story, you can do that at thecognitivestory.com. And of course, we'd be glad to get in touch with you, and of course to collaborate, whatever else it might be. But of course, though, that sums up what I had to say about the Cognitive Story and how we're using the power of cognitive to live better lives. And so hopefully in the past 30 minutes, I've been able to convince you as to why I believe that artificial intelligence is most definitely good news. And of course, whether it be answering your questions quicker, or whether it be controlling a drone via text message, whether it be creating and generating music, or whether it be giving communication artificially to those who cannot communicate naturally. I'm sure that you agree that artificial intelligence is already such an integral part of our daily lives that it is already our present and will most definitely expand and grow exponentially in the future. Thank you very much. That's what I had to go over today. I really do hope you were able to learn something from this talk, or maybe, of course, enjoyed this talk. If you'd like to get in touch, please do on any of the following social media. I think we might have around a minute for a Q&A. If you'd like to ask me any more questions, though, you can actually ask me outside. I'd be glad to answer them. And if you'd like to ask me any more questions, you can actually ask them to me on social media. I will be here I will be here today, and I will be here tomorrow as well, because I've got a workshop, so I'd be glad to answer your questions. But I think we've got a few more seconds left, so if anybody has any questions, please do ask them. I'd be glad to answer your questions. Just put your hand, oh yes, I think you have a question.
So Tanmay, great presentation.
Thank you.
IBM Watson defeated Jeopardy back in 2011.
Yes.
When you were 7 years old.
Yes, yes.
In the last 6 years, we haven't seen too many actual use cases in large-scale deployment from IBM Watson. We're still talking about use cases in small bits and pieces here and there. So what do you think had been the challenge? Why haven't we seen last 6 years Watson taking over the world?
Well, let me talk a little bit about this. Well, Watson, if you think about it, is actually doing quite a bit. I guess you are right there. It's not deployed at a large scale just yet, but it is actually being used in many different countries, including India, for things like, of course, cancer treatment in terms of healthcare. And one example that I like to give is actually Watson has a system where doctors and specialists can actually feed in information about a patient, and it can return different types of medicine that Watson believes could help this patient. And so specialists were able to actually feed in information about a Parkinson's patient and all of their symptoms, etc. And what happened is the end result, out of all the medicines that Watson returned 11 medicines that humans never thought had any link to Parkinson's whatsoever. We had never encountered that in our research. However, once doctors took a closer look at this, they did some more research, they found out 10 out of those 11 medicines that never had any link to Parkinson's were actually more effective than medicines that were already out there and known to work for those with Parkinson's. So I'm not exactly too sure, of course, about the sort of the history of Watson, because of course, unfortunately, I do not actually work for IBM. I just absolutely love to work with their services and actually use their services in my applications to create smart applications. But I will say, though, that I do know that Watson is, of course, being deployed, and I think we're going to be seeing a lot more of Watson in the very near future. Thank you. Does anybody else have any questions? I'd be glad to answer them. Any more questions? No? Oh, yes, I see a question there.
A kid of your age would like to have fun in the world, and then you find fun in AI.
Yes.
So, how did you fix the dilemma within your mind?
Well, there are actually quite a few different ways. Well, think about this. Generally, I started coding when I was 5 with the help of my dad. But what happened is when I was around 11 and a half, or about to be 12, I actually stumbled upon IBM Watson, which was my first venture into the AI world. But I won't be talking too much about what I've been doing and how I actually got into AI. But really, I believe AI is fun, and I love programming because I'm able to see all the different possibilities that AI actually has in these fields. Like, for example, it's generally fun knowing that we're able to help Boo communicate with the outside world using the power and really the intelligence that artificial intelligence provides us with. And so generally, I absolutely love working with these different services and of course programming and of course contributing to all of this, contributing back to the community and how they've helped me learn all these different things. Like, for example, artificial intelligence, cognitive, all these algorithms. I've been able to learn this, and that's also why I absolutely love to share share my knowledge with others to basically fill that learning gap, that knowledge gap that exists for example, artificial intelligence and cognitive, to bring this technology to those who haven't learned it yet and make it much easier for people to actually learn about these technologies. So there are lots of different reasons, but it's mainly because I absolutely love seeing what AI is doing for the community and for people, and of course how I'm able to make a difference in other people's lives by of course sharing whatever I learn about AI with others as well. Thank you. Thank you. Thank you very much. Oh, sure. Yes, thank you.